Okay, I'm sure it's recorded. Just say recordings in progress, but anyway. So we want to find x-intercept. What's true about y?
The y equals 0.
Exactly. So you're crossing the x-axis, obviously. So how would I solve that? What would I do?
You would put 0 to the power of 2.
Exactly. So it's still 0 equals 4x plus 64 because now the radical goes away.
Mm-hmm.
So negative 64 equals 4x. X equals negative 16. There you go. Not that bad, right?
Yeah.
So that's now. How about your y-intercept? What would you do for that?
Put x to 0.
Exactly. So you get y equals root 64, which of course is 8. Now let's talk about graphically what's happening. Graphically what's happening is crossing the x-axis at negative 16, right? Which is way over here. And crossing the y-axis at 8. And radicals can never be negative, right? Otherwise it'd be imaginary. So it's actually going to start right here. And it's going to rise like this. And it's going to keep rising like that.
Mm-hmm.
Now, another way you could approach it too, you could pull a 4 out and then root the 4, which looks like this. And that becomes a transformation. But we could talk about that later. But it does shift 16 to the left, but not up or down. Because root x on its own as a parent function would be a 0, 0 for the endpoint. So, but anyway, I'm kind of going on the deep end there. So let's just do 2 next. We just want x, y intercepts. What's the x-intercept here?
Oh, negative 4.
4, actually.
Yeah.
Now, this is a trick question. What's the y-intercept? If you plug in 0 for x, what happens?
Then it becomes a negative square root.
Yeah, you can't do that, right? And in fact, actually, that's going to look like this. So it never touches the y-axis. Now let's look at 3. Oh, geez, sorry. You want to break it down like this. Well, actually, I don't know why I'm even doing that. Well, actually, no, I should do that. I should do that. So it's it kind of looks like a parabola a little bit. It's kind of weird. It's kind of flat like this. And it's kind of like that. But anyway, the y-intercept is going to be negative 25. Now, taking a look over here, what do you think the x-intercepts are going to be? Now that I have it factored. So remember, you want y to be 0. So either this has to be 0 or this has to be 0. So we'll start with the first factor. What would make that 0? If you set that equals 0, x squared minus 5 equals 0. So we isolate x, what do you get?
Give me 1 second. Sorry.
Actually, don't use a calculator. Just move the 5 over square root. We just do it mentally. When you move the 5 over in square root, what does it look like? Plus or minus
5.
roots. That's all you have to say. Say no more. It's that simple. I know you want to calculate it. Don't. Actually, we prefer exact answers. That's better. Does that make sense?
Mm-hmm.
Okay. So remember, factor it. Set each factor equals 0 and just solve for x like you would any other equation. Don't overcomplicate it. If it's nasty, so be it. Deal with it. That's all. Okay. Then next up, number 4. Again, remember, a y-intercept was when, sorry, an x-intercept was when y is 0, right?
Mm-hmm.
So when I solve that, what does x equal?
4.
Perfect. Good. Great. Now let's flip the scripts. Let's plug in 0 for x and solve for y. What does y equal now?
10.
Plus or minus? You square rooted. Whenever you square root and solve an equation or solve a variable, you have to put plus or minus. It holds 2 values. Okay, symmetry. Be symmetric about the x-axis. It means that if you were to fold along the x-axis, it has to be a mirror image of itself. So it's going to look kind of like this. That was very sloppy, actually. We should be better than that. Sorry. You may want to label some points here. The 2 dots are just labeled. What are those coordinates?
0, -2.
Good. How about the other one?
4, -1.
Great. So what happens is that when you have x-axis symmetry, you have to change the sign of y. So that's one portion. And then the other portion, -4, 2. So you have -4, -2. And then that's at 0, 4. And there we go. So you see how the x-axis, see if you're like to cut out a square piece and fold along the x-axis, you see how they map onto each other?
Mm-hmm.
So now you want y-axis symmetry, so you want the x values to change sign. So you want something kind of like this. Which, by the way, I think also has x-axis symmetry too, but definitely if along the y-axis, they map onto each other.
Mm-hmm.
Yeah, that's kind of interesting. Actually, no, sorry, it doesn't have x-axis symmetry. I lied. It's just y-axis symmetry. Then origin symmetry is a rotation. And about the origin. The origin is kind of like the pivot point. So what happens is that the, actually I should know this. So the x and y values both change sign. So so you'd have a point. Well, it's kind of funny. -4, 2. So you have a point at 4, -2. 0, 4. So you have a point at 4. Hold on a sec.
I've been just doing it as flipping over the center point.
Wait, yes. Yeah, because you have to make sure indicate symmetry. Excuse me. Why am I struggling with this one? I think it's supposed to look like this, actually. Yeah, so if I rotate 180, yeah, I think that's what's supposed to happen. Um, Kind of funky. Yeah, but that would get you the same thing. Just trying to think. Um, I think you just switch a sign of X in, or sign of Y. No, I think switch sign of both. Yeah, I don't think you swap the coordinates. That was dumb. I think you just change the sign of X and Y. Yeah, because notice you have a point at -4, 1. You have a point at 4, -1. Or I had a point at 4, -1. Now I have a point at -4, 1. But here I have a point at 4, 4, 2. Now a point at 4, negative. Sorry, geez, I'm really screwing up here. You have a point at -4, 2. Now a point at 4, -2. Okay. Have you guys talked about odd and even symmetry?
Yeah.
Okay. Do you know what that is?
Yeah.
So I'm running two types. What would the first type be called?
The odd one, I think.
That's even, actually.
Oh yeah.
The reason why it's even is that the sign changed. The y value does not change sign, so it looks like this, like y equals x squared. And here, that's y equals x cubed. That's odd. So hopefully that makes sense.
Mhm.
Okay. So now what I'm going to do is I'm going to get y by itself here. Wait, let's come back to 8. That's kind of a funny one. Let's look at 9. So what you're going to do is you're going to deliberately switch x and negative x. If it stays the same, that's an even function. Whereas here, so in order to be odd, all the signs have to change. But some do, some don't. The first one does not, the second one does, so that's neither. And then here, oh, it's just a tricky one because y is in two different places. I guess you could say x equals xy squared. But it's kind of funny because really y squared equals 1, which basically is an even function. Actually, I think we'd be, well, that's what the Ansky says. Okay, so number 9 was a y-axis. Okay. Yeah, I can see how it's probably all of them if you graph it. Yeah, because you can rotate 180, get to the same place. And symmetric both the x and y axis. I think in this case, you just want to graph. But if it's even, that's y axis symmetry, just so you know. When you have these tests, you have a calculator or you don't get a calculator.
We don't get a calculator.
Okay. So you're gonna have to do that process of f of negative x, f of x. Okay, so let's talk about 11 through 14. How can you tell something's a function or not?
Oh, if the x value, like there's repeating y values to x values.
Yeah, so actually, you don't want repeating x values, which we do here. So that's
Yeah.
not a function, that's no. That's yes. And then how about when you have a graph? What do you do?
I'll draw a line and see how many times it intersects.
Yeah, if vertical lines cross more than once, that's also no. And here, they just overlap. So that's also no. And then these should be pretty straightforward. How'd you go about 15?
Just plug -5 in for x and solve it.
Yeah, I trust you could do that just fine. How about 16?
Plug in x for x minus 1.
Right, replace x with x minus 1. Now it does want you to simplify it, so you do have to FOIL and distribute. Be careful. Make sure you do that right. And that's 4x squared minus 2x plus 1. And then go and distribute. Yeah, so you get that. So you can factor out x squared. And then you could write like this. Ah, geez. Then when y equals 0, what values of x would make that true?
Plus 4 minus 4.
Mm-mm.
Square root of 4.
Plus or minus what?
Square root of 4.
Oh, sorry, square root of 4, which is what?
2.
And then, or just 8, right?
Yeah.
Okay, good. And then this should be factorable. Go ahead and factor that.
-2 and 15.
I like that. But what you need to do, um, so you could, how are you factoring these? How do you usually do it? Like, what's your process?
Do the x thing.
Okay, but after that, what do you do after that?
I just think about numbers and try it out.
Okay, you can do that.
Yeah.
I appreciate your transparency. So let me show you a couple ways you can do it. You can rewrite it like this, because you could drive yourself a little bit insane if you can't find them. So I'm going to suggest we try something different instead of trial and error. So you can do that. So the 13x gets split into 15 and -2. And then you factor by grouping. Where you factor out 3x from the first group, you get x plus 5. Factor out -2 from the second group, you also get x plus 5. So what do you get? 3x minus 2 times x plus 5. That's it. And of course, then you get 2/3 or -5. Now, another way you may like a little better is what I teach my students in Algebra 2. And I kind of did this, actually, I've been doing this for a long time. I started this in Algebra 1 about 19 to 20 years ago. You have 3x squared and -10. And then you split the 13x into 15x and -2x. Now, if you think about it, what's common in that first row between 3x squared and -2x? What factor do they share?
X.
Yeah, exactly. And then I'm gonna put 3x there because isn't x times 3x squared?
Mm-hmm.
Yeah, exactly. Then this has to be 5 because 3x times 5 is 15x. And that's to be -2 because x times -2 is -2x, or 5 times -2 is -10, and voila, we have the answer. So you could go about that way also. So and you'll have this video that you can review. Okay, how would you go about 19? What would be your process for that one?
Said the square root of x minus 2 equals 4 minus x.
Okay, good first step. What's your next step?
And then I would put 4 minus x to the power of 2.
Before that, what about that -2?
Um, Add it to the other side.
Yeah, because it's be cleaner, right?
Yeah.
Because otherwise you're gonna make it worse for yourself. Because then you have to FOIL that. You can't square the root x -2 separately, because that would be dissipating the order of operations. You'd have to then FOIL it. But why? Right? That's more work for yourself. Let's make it less work just by moving that 2 over. Now you square both sides. See how I got that? And then I could factor. And then you can keep going, right?
Mm-hmm.
And boom, 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 we got it. Actually, just to make sure, if I plug 9 in, it actually doesn't work because you get root 9 minus 2, which is 1. You get 4 minus 9, which is -5. No good. Doesn't work. If I plug 4 in, it does work. I get 0 equals 0. The domain. Domain is the values of x that are allowed. There are 2 reasons why they're not be allowed. Well, when you get to other types of functions like logarithms or trig, but I don't want to get to that for now. Radicals, or sorry, square roots, or even roots. Let me rephrase: even roots or denominators. So we can't square root negative numbers. So what would be my domain for number 20? Or what value of x? What values of x would not be okay?
-1.
Sorry, say again.
Can x be 0?
Of course, it could be 0. Yeah, no problem. Because you can root positive numbers. We can't root negative numbers. What would make it negative? Well, what happens?
-13. I mean 13.
Right, but we're gonna say anything less than -12. Meaning it could be bigger than -12.
Mm-hmm.
Now, do you guys do interval notation?
Not really.
Okay, we should start talking about that eventually. Have you seen that before?
Yeah.
Okay, so do you know what that means when you put a bracket?
Mm-hmm.
What does that mean?
It means it doesn't go past -12.
But it includes it.
Yeah.
And then the infinity means it goes forever to the right.
Mm-hmm.
So, I mean, either way is valid, but the trend is to write it in interval notation. Now,
Mm-hmm.
here we have a denominator. Denominators can never be 0 because it can't divide by 0. What value of x would make that 0?
7.
Exactly right. So x cannot be 7. So you can say all real numbers except 7. You can say that if all real numbers. Now, if you write interval notation, you would write like this. That's what happens there. Here, factor on x from the bottom. X would equal 0, -15, but you don't want either of those situations. So you have to say all real numbers except 0, -15. Actually, say your teacher writes it. Okay, so he does, yeah, all real except 0, -15. Okay, he just writes it out. Okay. Yeah, and look at 19. You said you should also got 9, but it's extraneous. It didn't work because when you plug it back in, it failed. Okay. Here at the home stretch here. Do you know what this function does with the double brackets?
I definitely do know, but I don't really remember.
It's called the greatest integer function. It's a step, or we call a step function. So, for example, if I plug in 0, well, you get 0 because the greatest integer that's so basically it's the greatest integer
Mm-hmm.
less than or equal to x. So like, if I plug in 0.1, what's the greatest integer or whole number that's less than 0.1? Well, 0, of course, right?
Yeah.
Until I get to 1, then it jumps. Then it jumps. Then it jumps. Then it jumps. So that's just if you have this. But because of the transformation, you have to multiply the y values by 2 and then add 2. So what's happening here, that portion, I have to multiply that by 2. Well, it's still going to be 0 anyway. But I add 2, so it's right here. Then the next one, which is supposed to be over here, if I multiply by 2 and then add 2, it'll be at 4. Next one, which is at 2, multiply it by 2 and add 2, that would be at 6. And so forth. Here, that -1, multiply by -2, but then add 2, just like that. So that's just kind of the trend that we're noticing now. Now here, you have to transform it by going 2 left, flip about x-axis, and down 1. Okay. So what I'll do, gosh, these are tough ones because it's just hard to do a table for them. But generally speaking, right, anything from 0 to 1 was 0. 1 to 2 was 1. 2 to 3 was 2. Then 1 to 0. Was -1. So what I want to do is you want to go 2 left. It's over here now. Flip over the x-axis, which just stays where it is, and then go 1 down. So it's like that. And the next one, which is over here, 2 left. So that's over here. Flip, which is over here, then take down 1. So now we know this is the general trend. So it looks like that. Yep. And then how are you graphing piecewise functions?
Sorry, what? Can you repeat that?
How are you with graphing these kind of functions? These are called piecewise because you have a piece of each one. How would you go about that? Well, we'll start with this one. How do I graph that? Just a line. How do you graph a line? Are you still there? Hello? I can't hear you.
I don't really remember how to do that.
How to graph a line? No, I think you do. You've done it before with SAT stuff. What's your y-intercept?
-1/2.
Nope. That's your slope. What's your y-intercept? Plug in 0 for x. What do you get when you plug in 0 for x?
-4.
Right. Okay. Does that make sense?
Yeah,
Because you're intercepting the y-axis. X has to be 0. Okay, now what is your slope?
-1/2.
Exactly. So you go down 1, right 2. But it's got to start at -2 because of the condition here, right?
Mm-hmm.
And it's not included, so you put a hole there, and you go like this. So you only do a piece of it, not the whole line, because of the inequality next to it. That's a condition that you want for x. With that said, how do I do the next one? What's my y-intercept here?
2.
What's my slope?
2/1.
Exactly. And it's starting at -2, which will be at -2 actually. And it just does this. So hopefully that makes sense for that one. So that's a piecewise function. Okay, so you definitely will need some extra practice. I don't necessarily think you should take this tomorrow. I mean, I think that you're okay. You like, for example, you know to find x, y intercepts here. You were familiar with symmetry, and even odd. You're a little, you're a little shaky, but you knew what to do about even odd. You just had to mix up. You knew how to find functions. Oh, we didn't do domain range. Shoot. Remember, domain is just x and range is y. So actually, let's talk about domain range for 13. What will be the domain for 13? So what is this? Oh, sorry.
Domain is like y, right? Or x?
Nope, domain's x.
Oh yeah, right.
Range is y. If it helps, think of it as alphabetical order. D becomes R in the alphabet, and X comes for Y in the alphabet. D is X, range is Y. Okay, so what's the domain for this one? What are the X values that would be valid here?
Or anything that's less than 0.
Perfect, good. How about the range? What would you say what the range would be?
It'd just be all negative numbers.
And positive numbers too.
Yeah.
So it's all real. Okay. For 14, what would your domain be? What X values are you noticing for 14?
It's from -1 to 2.
Your otter's being weird. Okay, we're really talking all the time. -1 and 2, but it's not between the two. So you just say -1 and 2 straight up. How about the range? What would the range be?
Or real numbers.
But what y value skipped over?
All real numbers besides 2.
Exactly. Good. And then for 11 and 12, just straight up, just state the x values and y values you see. Yeah, plugging in 15 you're fine, 16 you're fine. Factoring, you want to kind of work on the technique a bit more. Domain, I think some work there is going to be good. And obviously, yeah, great integer function piecewise you're shaky on, so we need to work on that too. So at least I can provide some extra stuff for you by tomorrow. That would be good. I'll take care of that. Okay. Um, Now let's look at this assignment here. We can probably go through one assignment, and then I think you'll want to get through these next three this week, and that will help us prepare for the next test. But I would say this test you're probably gonna want to do later this week. Maybe after we meet one more time, maybe after Wednesday, it might be good to do this one while you
Uh-huh.
keep working through this, and then maybe this one can be done at the end of the week. Um, let's see here. Here. Oh, that's just I didn't see that. Okay. Um, well, what are we supposed to do here? I'm supposed to just graph these?
I think
I,
it's supposed to depend on whatever.
I think it's graphing.
Yeah, because I don't remember what we did for that day's lesson.
Okay. So here's what I'm gonna suggest that you do. Um, I don't recommend it because you really do need to practice to do this by hand.
Mm-hmm.
But just so you can get through the homework, we can use Desmos. Like for example, so if I were to do y equals negative x to the third minus 1, and see, you just plot those points and you make the graph.
Mm-hmm.
Like next thing, do the same thing. Y equals, and just, I mean, but to be proper, um, what I probably would do, if you just draw the graphs, you might think you just copied it from Desmos. So in order to be, you know, I would write the parent function. And you'd say like, okay, well, shift one down because it clearly went one down and it flipped over. Actually, you need to reflect first. Reflect about the x-axis, shift one down. Because what's happening here is, generally speaking, your function looks like this. So your a is -1, which is when a is negative, that will reflect about the x-axis. And your k is -1, meaning you go one down. K is responsible for going up and down. H is responsible for going left and right. So I would probably just state something like this here, and then just show the graph, just to show that you understand what's going on. Like, let me show you another one. Yeah. So yeah, so like I'll punch this into the Desmos, right? Y equals. So it's pretty clear when 5 left and 2 up, and it flipped. So just say that and do the graph. Same thing with 33. 42. Well, third end's like 28 because that's um so that'll go 2 right and shift by 3, or sorry, vertical stretch by 3. But 42, you could do this. Y equals, excuse me, 6 minus absolute value x plus 5. you get that?
Mm-hmm.
So yeah, so you can say went 5 left, 6 up, and flipped over. And you have some more over here. Um, so definitely, yeah, I think it would be good to work on that this week, and we could check and make sure you're doing it correctly. So I will ask you to take pictures and upload it. But again, you have Desmos, so I mean, you could totally just kind of get away with that. Let's look at the next homework assignment. That's gonna be 1.7C. Okay, my guess is you're gonna want you to write the equations for these. So first of all, we need the parent function. So for number 15, so what will be the parent function for this? The most basic. Y equals what?
Uh, x x2. So
Exactly right. Now let's take a look at A. How would you write the equation for 15A? Y equals what? How compare to Y equals X squared, which is this.
-1.
Good. Going one down. I like that. That's good. Very nice. How about B? B's a little bit more involved. How'd you say that one?
Negative
Mm-hmm. Then X, and what do you?
x
And
x
then
-1.
+1,
Oh yeah, +1.
because one left always is the opposite. And then
Yeah.
how about the end?
Would just be +1 again.
Exactly.
Right.
Yeah. Remember, Y equals A, X minus H squared plus K.
Mm-hmm.
Okay, let's jump to a different one. Let's take a look at 6, 6. Okay, that's a square root function.
Mm-hmm.
So then, generally speaking, but look at this. Look at the beginning point. It didn't move, right? It didn't move left or right. Didn't move up or down. Because generally, it's going to look like this, right?
Yeah.
So what you could do is you'll say Y equals A root X. Now plug in 16 for Y and 4 for X to solve for A. What does A equal?
8.
Exactly. Yeah, so you get that. And you can do the same thing over here, right? You get -1/4. So that's what happens to that one. Okay. Got a few more minutes before I hop on my next call. So these are pretty straightforward. You're really just adding, subtracting, multiplying, dividing, right? So I mean, just add it, right? That's done, right? That's part A.
Mm-hmm.
Part B is just this: X squared plus 6 minus, done. Part C, we can't really multiply them together, so just see it like this. Done, right? For part D, you do one over the other. But then they want the domain of that. Okay. What value of X is not okay? X cannot equal what?
1.
Right. And also have to keep a positive inside. So 1 minus X has to be greater than 0, or negative
Mm-hmm.
X is greater than -1, or X is less than 1. So in this case, just say X is less than 1. Don't include the 1. You're good.
Mm-hmm.
Um, here, you plug in -1 to both F and G separately, and then subtracting. So if I do that, I get 2 and -5. And if I subtract, I get 7. That simple. Yeah, these homeworks are pretty short, so that's good. You know what this means with the open circle or a non-filled in circle in between the two letters? You know what that means?
I don't exactly remember.
You plug G into F.
Oh yeah.
Yeah, and it's a weird symbol that you don't see too often. So this goes inside this.
Mm-hmm.
You get 20 minus 3x. Okay, hold on 1 second. Okay. Let's see here. So G of F, yeah, then you just do the other way around, plug in this into this.
Mm-hmm.
And then G of G means you plug G into itself. So you 5 minus parentheses 5 minus X. And if you clean it up, you just get X. So does that make sense?
Mm-hmm.
Yeah, I think so. Yeah, you got been this, I think. Hold on. Yeah, I guess that makes sense. Because that's not inverse, it's the inverse of itself. Yeah, I guess it is. Yeah, yeah. Yeah, because it'd be symmetric about y equals x. Okay. Anyway, I'm just thinking about some other topic. Okay, we can probably squeeze in one more. Um, but I think the goal is to try to get all those homeworks done at least. Oh, wait, inverse. Yeah, there you go. Yeah, definitely I was correct in assuming that. Yeah, so to be an inverse, it's got to pass the horizontal line test in addition to the vertical line test. So see how that fails the horizontal line test for 40 and 41. That's no. But those pass as those are each yes. Now, do you remember how to find the inverse?
Yeah.
How do you find the inverse?
Oh, you just flip the slope, I think.
Not no. What do you flip? If, for example, if y equals 2x
Yeah,
minus 3.
you make the x y.
Yes, good. You got it. Yes. And then you get y by itself.
Yeah.
And you get x plus 3 over 2. And then they want you to state the domain of that, which will be all real numbers. Now, one way you could do this is if you use Desmos, take a look at what the range is for the original function, the range of the original will be the domain of the inverse. So like, for example, that range will be, or that graph I think would look like this. So that range will be is y is greater than or equal to -2. So domain would be x is greater than or equal to -2 for the inverse once you work it out. Yeah, like here for 61, that's kind of a crazy, or look at 62. That'll be our last one for tonight. So you can cross multiply. It's gonna be a little complicated. And then if you move things around, factor out y. And that's how you get by itself. You factor out the y after you, so you collect all the terms at y and factor it out, and you should be okay. Hope that makes sense. And if you state the range for that one, I think it's all real except 8. I'm sorry, except 4. You should graph to get the range. But then that would be the domain would be all real except 4, which actually makes sense because wait, shoot. Does that make sense? Wait. Wait, did I make a mistake here? Hold on. X equals 2y plus 6. Oh my gosh, I can't believe I did that. Factor out 2. Hold on. I messed up my pretty royally. Yeah, we've been fine. Yeah, because then you get 2xy. Yeah, x minus 4. Got it. And then divide by 2. Yeah. So anyway, x can't be 4. All right, we're going to stop there for tonight. So what I'll do by tomorrow morning is do some practice for the first unit test, and I'll create this like spreadsheet and as well as the Google folder. I'll ask you to work through the homeworks we just talked about,
Mhm.
and then we'll check in on Wednesday. And if for Wednesday, let me look at my calendar here really fast. That's the 23rd. What time are you home from school usually?
Like 4 or 5.
Um, could you
Or I can do
do?
earlier too.
So sorry, what time are you home again? You said 4
Uh,
o'clock
yeah, I
or
said
5 o'clock?
usually 4 o'clock, but I can go home earlier if you're
Um,
like okay with the earlier time too.
I actually no, actually, can you meet at 4 or would 4:30 work?
Yeah.
Let's do 4:30.
Mm-hmm.
Just so you don't feel rushed. Okay, so I think we're okay there. Okay, cool. So perfect. Great. I'll also look for an email from you by tomorrow, and we'll yeah, and we'll just touch base then.
Mm-hmm.
All right, sounds good.
Thank you.
Bye.